In this video, we're going to be reviewing inverse functions. So we've defined an inverse function before, a while ago. An inverse function is the reverse of the original function, and we use this notation. It's a little confusing because we just learned about exponents with this negative one here. So these two things mean different things. So when that negative one is right next to your function name, this represents the inverse. If for some reason I really want to do a negative exponent, I would put it after, and we know negative exponents make these things fractions. All right, so this negative one after doesn't really happen very often, so this is never really going to happen, definitely not in this class. So this little negative one right next to f is not an exponent, it's just representing the inverse function. And the important thing with an inverse function is it just switches the inputs and outputs around. So my input here, the thing I'm putting into f is a, and for the inverse, that's the thing I get out. And then the thing I was getting out of f is the thing I'm putting into my inverse. So just the switch is really all you need to know about inverses. All right, so one thing that is kind of interesting with inverse is how their graphs are related to the original function. So we have this graph of f. What's the graph of the inverse going to be? Right, how can we even start this? We have a graph and we don't know the equation, we don't know stuff, but we do know any point on a graph, the x value is the input and the y value is the output. So on this graph, we have the point 0, 0 on my original function f, which means when I switch it, it's still 0, 0, and that's also on my inverse function. So this point here is also my inverse function. I have the point 1, 1 on my original, which when I flip the inputs and outputs is also 1, 1. So nothing really interesting has happened yet. We're getting the same points. But this point here is a nice point. On my original graph, that's the point 2, 4. And when I flip that to the inverse function, it's going to become 4, 2. All right, so points just flip, input becomes output, output becomes input, and now I get this point on my inverse function. At this point, it's not exactly 3, 8, let's just say it's 3, 8, just so we can have another point for reference. So if 3, 8 was on the original graph, inverse we flip it, that's 8, 3. So we're going to have 8, 3 on my inverse graph. All right, so my original graph is kind of sliding up here. My inverse graph, you can kind of see with the blue dots, is going this way. So the inverse graph, the whole thing is going to look something like that. And there's this really interesting thing that happens if you were to put kind of a diagonal line through the middle of the graph. Then these two are mirror images of each other over this line. So this should probably go out here a little bit more, because the mirror image of that red line over there, and then this line is going up, we flip it over, it becomes that. But all we're doing is just flipping points. So here's one for you to try on your own. There's this original graph g of x. Try to use the points on g of x to graph g inverse. So go ahead and do that, and I'll show you the answer in 3, 2, 1. So your answer should look something like this. And we can kind of see the points. So 3, 4, switch to 4, 3. 2, 3, switch to 3, 2. 0 or 1, 0, switch to 0, 1. And 0, negative 5, switch to negative 5, 0. So you can kind of see all these lines. I'm just switching to another point, and you can see it kind of mirrors along this diagonal black line. All right, so you can do it really quick without doing individual points by just putting this diagonal line and drawing it, but I'd like to do it with the points so I can kind of get my graph more accurate. All right, the other thing is just using function notation, doing the same thing we just did of switching the points in and out. So if we have these values that we know for my original function, what is the value of the inverse at 6 going to be? So just remember that this input that I'm trying to put into my inverse should be an output, which is all these ones, for my original. So I'm looking here. All right, my original function, when I put in 4, I get out 6. So my inverse, I flip it. Now I'm putting in 6, and I'm going to get out 4. All right, so I'm just doing the reverse of this point. All right, these two things switch places, and it becomes the inverse. All right, here's another one, f inverse of 4. All right, again, just think about what it's going to be. We're trying to flip one of the points we're given. All right, this 4 that's in the parentheses should be on the outside, so this is going to be equal to 1. So we're just flipping this point there. All right, and then for you, what do you think f inverse of negative 2 is? Think about it for a second, pause the video if you need to. And the answer for this one would be 3, because it's this point, but just flipped around. All right, so a quick summary of inverse functions. All right, the inverse function is just the reverse of the original. We just switch the x and y values, whether we're graphing it or using function notation. And like I mentioned in that earlier slide, don't confuse that -1 with an exponent. We just learned about negative exponents. But when that -1 is right next to your function, that's inverse, not a negative exponent.